Now that you have a sense of what the quadratic formula is and how it works, let's dive a little bit deeper into it. So we're going to look at a very specific part of the quadratic formula, which is called the discriminant, and it is the piece that is underneath the square root. Now this is a very special part of the equation because it will tell us a bit about what the solutions to the equation are going to look like. Now actually what I'd like to do is come back to this chart at the end of the video. So let's actually flip to the back of the notes and go through these three questions, and then we'll come back to that. But pay attention to that part of the equation, part of the formula. Pay attention to what happens underneath the square root as we go through these. So what we're going to do is just go ahead and start using the quadratic formula here. So it's negative b is 6, that's negative 6, plus or minus the square root of b squared, so 6 squared is 36, minus 4 times a, which is 1, times c, which is 8, all over 2 times a. Well, a is 1, so that's going to be 2, just 2. Then what we've got is, let's see, negative 6 plus or minus square root of 36 minus, and then 4 times 8 is 32, all over 2. So that's negative 6 plus or minus the square root of 4 over 2. And this should all be x equals. Alright, so you can see the number underneath the square root is 4. Alright, so in this case then we can just take the square root of 4, that's fine, no problem. Negative 6 plus or minus 2 over 2. And so the two solutions we get, one is negative 6 plus 2 over 2. So negative 6 plus 2 is negative 4, divided by 2 is going to be, negative 6 plus 2 is negative 4, divided by 2 is negative 2. Then the other solution is going to be negative 6 minus 2, which is negative 8, divided by 2. That gives us negative 4. Alright, so the two solutions then are negative 2 and negative 4. So these are both real numbers, and the reason why we got real numbers is because when we took the square root of 4, we got a real number. We can take the square root of 4, no problem there. Let's look at x squared plus 6x plus 9. Let's use the quadratic formula on this. So that's going to be x equals negative b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 9, all over 2 times a. And again, a is 1. And when we simplify it, this time something different is going to happen. Under the square root, we get 36 minus, and then 4 times 9 is 36, over 2. And so what we end up with then is negative 6 plus or minus the square root of 0 divided by 2. Well, the square root of 0 is 0. So what we really have then is negative 6 plus or minus 0 over 2. Well, we could again break this apart into two separate equations. We could get negative 6 plus 0 over 2 and negative 6 minus 0 over 2, but these are really the same thing. If you add 0 or subtract 0, nothing changes. So these are both going to be negative 3. And so what happens here, when we get 0 underneath the square root, then we get the same number twice. We get 2 of the same exact solution. And so when that number underneath the square root is 0, then 2 of the same solution. Okay, the third case that we can have, as you might guess, is going to be where the number underneath the square root is negative. So let's do just that. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, in this case c is 10, all over 2 times a. So we get negative 6 plus or minus the square root of 36 minus 40, all over 2. And so we get x equals negative 6 plus or minus the square root of negative 4 over 2. And now we have a negative number underneath the square root. And so when we try to work this out, well, the square root of negative 4 is 2i. So we get all this over 2. We can simplify this a little bit. So it's negative 6 and 2i, those can both be divided by 2. So we could write this as negative 3 plus or minus I. And so you can see then that the two solutions we get are imaginary solutions. Now, if you want to write these separately, you could say one is negative 3 plus I, and one is negative 3 minus I. That'd be just fine. Or you could pack them together in this one with a plus or minus. But the point here is, if you have a positive number under the square root, you're going to end up with two real numbers as your solutions. If you end up with a 0 underneath the square root, you're going to end up with the same number twice, because adding 0 is the same thing as subtracting 0. And if you end up with a negative number underneath the square root, then you're going to end up with imaginary numbers because you're taking the square root of a negative. So let's flip back to this chart now that we've gone through those three cases. So when b squared minus 4ac, when the thing underneath the square root is greater than 0, that's positive, you're going to end up with two real solutions. So you're going to have two real x-intercepts. It will cross the x-axis at two different places. And you could also have it facing downwards. Either way, it's going to cross twice. When you have b squared minus 4ac, that's again the number underneath the square root. When that is 0, you get one solution, but you get it twice, so it's a duplicated solution. And what happens here is that you're going to have the parabola come down and touch the x-axis and then move away. So it doesn't actually cross it. It just comes down and touches it and bounces away. And you could have it come up from the bottom and do the same thing. Either way, it's hitting the x-axis in one and only one place. And that's because you get that solution repeated. You get it twice. And there's no other x-intercepts. It's just that one. And then if you have b squared minus 4ac being negative, that's less than 0, then what that means is that you're going to get complex solutions. So it's not going to hit the real x-axis at all. Something different's going to happen there, which is something that we'll look at in class sometime. But basically, it's going to be either entirely above or entirely below the x-axis.